All right, so we're going to be recording today. Again, welcome everyone to Love Data Week. I'm Emily Kilser, the Scholarly Communication Librarian, and we are delighted to be participating in this international celebration of data, which does deserve all of our love. So I'm here with Kathleen Flynn, who's the subject librarian for the physical sciences, mathematics and statistics, computer science and engineering, and Dr. Sandra McGinnis, who's the lead researcher for UAlbany's Data Management and Analytics Center. So we're going to dive right in. If you can do next slide, please. So why research data management? Funders and journals are more and more requiring data management plans and data sharing as part of the publication process or part of the funding requirements. So why are they doing this? Ultimately, it's to encourage an ethical and robust research ecosystem. So the more data is managed, it's better shared, other people can make use of it and replicate your findings. And so this all feeds into a more robust research ecosystem. Additionally, sponsored programs is requiring a data management for funded projects. So those are sort of the hard drivers, but at its heart, data management and data management planning will ultimately save you time and prevent data loss. It makes it easier to share your data and increase your research impact. With that being said, data management plans aren't necessarily intuitive. This isn't something that you may have learned in your graduate program or as part of your training as a researcher. But there are tools available on campus to help. We will be looking at the DMP Tool, which walks you through the process of data management planning and connects you with UAlbany specific resources. It also has funder specific templates baked into it. So you can share this, you can start a data management plan, you can share it with your colleagues, and you can also solicit feedback from the data services group. That's one of the services that we provide. So we wanted to sort of introduce you to that support on campus upfront, because what we're going to describe in what follows might seem overwhelming, but don't worry, there's help. So next slide, please. So when we talk about data, what are data? Defining data can be difficult because data are heterogeneous, right? They can be quantitative or qualitative, observational, experimental. You might be working with corpora of text or images. Research data is not. What research data is not can be helpful might be easier to describe. So the Office of Management and Budget does not include trade secrets, plan for future research, preliminary analyses, or personal and medical information that would invade somebody's medical or personal privacy as research data. And the Organizational for Economic Cooperation and Development also does not include lab notebooks or preliminary findings as research data. So data ultimately are content, anything on which you perform analysis. So that's sort of, we just wanted to start with the basic definitions. So next slide, please. To understand data's role in the research process and how to manage it better, we wanted to do a hat tip to the research lifecycle. And by identifying the different roles that data plays in different points of the process, we can better identify what the management needs for the data are. So for example, in data planning, you want to start with your data management plan. You'll identify security, storage, and sharing needs that your project may have. When you acquire data, you'll want to think about documentation and organization. With analysis, you'll have concerns related to storage and backup. And then in the publication and data sharing section, that raises questions about intellectual property, what repository you'll share your data in, and then preservation and reuse, which includes discovery and citation, which starts the cycle all over again for your data. So next slide, please. Within that framework, we wanted to share a quick video to illustrate why all of this matters. And I'm going to mute.
Hello, my name is Dr. Judy Benign, I'm an oncologist at NYU School of Medicine.
Hello, Dr. Judy Benign.
I read your article on B-cell function. I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires that you share your data.
I did publish in Science.
Then I am requesting your data. Can I have a copy of your data?
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Okay, so that's cute, right? But you don't want to be the bear or the dog or whatever the brown creature was. So let's dive into what data management is and how it can help you. So data management and data management plans are two distinct things. Data management are actions that are related to taking good care of your data. You do this at the start during and after a project because good data management practices help you in the long run. A data management plan, however, describes what you will do with the data during and after a project. With good data management practices, your data will be easier to find and understand, less likely to be lost, more likely to be usable during the project or later. So data management really gets at taking good care of your data, which is an important product of your research. Data sharing emerged around the same time as data management requirements, and so we'll explore that a little bit later. So while a data management plan or DMP may be required by a funder, by understanding and practicing data management, you'll be taking better care of your data, which ultimately helps you. So next slide, please. What's at risk if you don't manage your data well? So the video was an amusing example, right? But there are real world consequences and costs when data are managed poorly. In this example, there was a wildlife biologist who provided GIS support for all of the staff. And when they left, that knowledge left too. And so it cost about $4,000, so a month's worth of work to salvage the data. And then some of the data weren't recovered. Next slide, please. So we have another example, and this is sort of larger scale. Poor data management really does result in cost and time and money. So this example here describes how people were incorrectly coded as being deceased by the Social Security Office. And even just thinking about what a headache that would be if you were one of those people, it gives me gives me shivers. So again, there really is a large cost in time and money. So poor data management can look from something as simple like, where did I put that file? Or why didn't I write down that information? Why did I name the field SAM1 and SAM2? To having your work appear in Retraction Watch, or for example, NASA of losing high quality footage of the moon landing because they got rid of the disk that was stored on. So next slide, please. Earlier, I mentioned that some funders are requiring data management plans and data sharing. Many of you may be well aware of this already. This started in 2011 with the National Science Foundation's data management plan requirement. And this now covers federal agencies with budgets over $500 million. Private funders are also including data sharing requirements as part of their funding obligations. So for example, the Bill and Melinda Gates Foundation, Howard Hughes Medical Institution, and Sloan. So why are they doing this? Again, from a funder's perspective, data sharing makes better use of resources, and it provides greater accountability to stakeholders. Data sharing also reduces barriers to accessing high quality data and supports new forms of research, so meta-analyses, which can increase the rate of discovery. Next slide, please. So we just wanted to show you and mention that journals also are now including data sharing requirements to address the reproducibility crisis. And by making data findable, accessible, interoperable, and reproducible or fair, good practices can lead to standards which really do improve the research landscape. Next slide. We wanted to show a quick example from a journal publisher. This particular example is from Wiley. You'll see that within their publishing catalog, some journals have data sharing or data availability statements as being optional. Some of them require these. And some journals may specify a specific repository for sharing your data, some don't. So it's a lot to keep track of and a lot to think about when you're working with funders, when you're working with publishers, and even just when, as you're trying to navigate your research project, taking good care of your data. So next slide, please. We've provided links to sample data management plans. We do plan to make the recordings available. And we can share the slides with the folks that are logged on here after the fact. So you can actually go to the links to explore these. Data management plans are not intended to be treatises. They're about 1 to 2 pages long. They're brief documents, they're living documents. So as your project changes and grows, that happens. The expectation is that you also edit your data management plan accordingly. So next slide, please. So why do you want to take the time to learn these practices? Depending on your funding, it might be required, like we said at the start, right? This data management, good data management practices will help you save time. They can increase your research impact. By sharing your data, you can get citations for it, and that's something that you can include in your dossier. You'll be preserving your valuable data, and you can really actively foster research and discovery. So now that we've convinced you of the value of data management planning and data management practices generally, you might be wondering what this looks like and how to do it. So to start us walking through these considerations, I'm going to hand the mic over to Sandra.
Sure. The first thing you want to think about when approaching your data management plan is what kind of data do you have and how are you going to organize it? And so the kinds of things that you need to think about around data collection are, first of all, the type, format, and volume of data that you've got to work with, how you're going to organize that data, how you're going to handle version control, because I think all of our projects spin into many, many, many versions of the same files, how you're going to conduct quality assurance for your data, and some thought to any transcription procedures and protocols that you may be using with your data. Next slide, please. So far as type, format, and volume of data, the first thing you want to include in your data management plan is a brief description of the data, including any secondary data that you may be using in your project. This includes content, type, coverage. For example, you want to note if you're using spatial data, temporal data, instrument-generated data. Your data may take the form of models, simulations, images, video. Data is much more than simply numerical codes in a database file. You also want to note how many data files of each type you expect to generate and how large they will be. That will help you to better understand your storage requirements and if you need to work with ITS for additional storage. And you want to talk about what software programs will be used to generate the data. Next slide, please. When you think about organizing your data, you want to establish some sort of naming conventions for your files. You want to make sure that you have a system of version control, and you want to think about how you're going to structure your directory and your folders so that you are ultimately able to find your data when you go back to look for it. Next slide, please. So as part of that process, you'll be developing some documentation around that data. And I'm going to turn it over to Kathleen Flynn from University Libraries to talk a little bit about the documentation process.
Thanks, Sandra. Okay. So your funding agency may ask you about what documentation you'll have and any metadata that you'll use during your project. And the metadata are just the data that describe your data. So they will answer the who, what, when, where, why, how questions about your data. And a metadata record can answer questions like, why was this data set created? Who created it? What processes were used during that creation? When were the data last updated? What kind of fields are in the tables? What do the values in those fields mean? Who can I contact to get more information? Especially if I'd like a copy of the data, are there any costs to get that data? Any limitations in the use of the data? And having good metadata and importantly documentation about it, it will help to preserve the usefulness of that data over time. So for instance, when you're working on your project, you know how you collected the data and you understand what the values in the fields are and what any abbreviations mean. But it's likely that in the future, you'll forget some of those details. And so the researcher in that Panda video had really poor metadata and no documentation and couldn't remember what the contents of the fields were and lost the contact information of the co-authors. So this made his data unusable to others and also to himself if he wanted to use that again in the future. So any metadata record is better than nothing, but the most useful metadata will use a standard. And a metadata standard will provide some structure to describe the data with some common terms and definitions and language. And that allows consistency between records and easier interpretation. So for instance, there's a common standard for dates, the ISO 8601 format, where you use 4 digits for the year, followed by 2 digits for the month, and then 2 digits for the day. And this is especially useful here in America since we tend to list dates as month, day, year. So using a standard will eliminate that confusion, and so any researcher or any students that will join the project in the future, or anyone who gets a copy of the data, they'll be able to understand how to interpret that year, that date. There are many standards available, and you may find that you need to use more than one, or that you can tweak one to suit your needs. There are some that are general purpose, like Dublin Core, and there are others that are a little more discipline specific, like Darwin Core. And the libraries can help you identify standards that may suit your project. And now I think I'll turn it back over to Sandra to talk about ethics and compliance.
So one of the important things you need to consider when you're working with any data involving human or animal subjects is issues of ethics and compliance. Next slide, please. One of the most important things you need to think about is how you're going to protect the privacy of human subjects. And your first stop for this really is your IRB protocol. The IRB can help you to identify any potential issues that they see in protecting your human subjects. You may also want to consult with information technology services, because part of protecting the privacy of your subjects is having adequate security for your data, both in storage and in transit. And here's a link to some of the protocols, standards, and procedures that have been developed around information security at UAlbany, if you want to check those out. You also need to consider if any of your data falls under any legal or statutorial data protections. Much education data is covered under FERPA. Personally identifiable health information is covered under HIPAA. If you're using data from the European Union, you may have to consider the GDPR requirements. And many federal funders are now requiring their researchers to provide a NIST 800 level of data protection. Next slide, please. Now, having protected data doesn't necessarily mean that you're not able to share your data. Both FERPA and HIPAA allow data to be released if it has been de-identified. But it's important to realize that de-identification of data can be much more complex than simply stripping out names, social security numbers, etc. And here are some links to resources about the best practices for de-identifying your data. And in fact, there are different requirements for different types of data. HIPAA specifically identifies 18 identifiers that have to be removed from your data for it to be considered fully de-identified. Some general tips you can use for de-identifying your data is that you can remove or replace direct identifiers with categories, for example, taking a specific age in years and collapsing it in 10-year age groups, using generic names, symbols, random values. You may use pseudonyms, but that can get kind of complicated, especially if you have HIPAA protected data. So it's best to use some other sort of identifier. You need to think about limiting indirect identifiers. The issue here is one of the potential for deductive disclosure, which means that, you know, you may be able to figure out theoretically that if there was a 49-year-old woman who received services in this health clinic on this day for this condition, who that woman is, because she's the only one of that age who received services for that condition that day. And so you really need to think critically about which of your data elements could potentially be used to identify individual people. And that may depend on what your numbers are within specific cross tabs. Again, one approach is aggregating data into ranges. So instead of, you know, using individual year of age, use 10-year age ranges, or instead of using specific date of service, use month of service, those sorts of things. It's recommended to use birth year instead of day, month, or year, which is far too specific, and use county instead of city. And there's many things like that that you can do to help secure your data. Again, some of the links here may be helpful to you in doing that. Next slide. So now I'm going to turn it back over to, actually, I'm not sure if this is Emily or Kathleen.
I got it. I'll take it.
I thought it was Emily, to talk about some of the considerations for storage and backup.
Okay, thanks, Sandra. So like Sandra said, another key consideration at the outset of the project is how your data will be stored. I'm not an ITS, but we are pointing you to their resources and general principles, right? So a good rule of thumb is to store your data in multiple places because lots of copies keep things safe. If you spill coffee on your computer and that's the only place where your data is, you may be in trouble, right? So there's a 3-2-1 rule, which is that you keep 3 copies of your data in 2 types of storage media, with one of those being offsite. Within DMP Tool, we have links to ITS policies and standards. So for example, and again, we've linked these resources here. There's ITS's file storage, recovery, and backup retention policy. That speaks to the fact that if data is stored on ITS storage solutions, they're automatically backed up and retained for 3 weeks. There are also servers that are dedicated to high performance, high throughput research, and those may observe different standards. ITS also provides a data classification standard and details about storage and security controls for category 1 or sensitive data. And they can work with you on data storage and security for, yes, Beth, we can send those slides along to everybody who's on the call, sorry. We'll be sure to do that. So ITS does provide information about security controls and standards, and that's something to be aware of. Next slide, please. So any research effort can generate a lot of diverse output, right? And relying on deciding what to select and preserve can be helpful if you base those on best practices. So next slide, please. These are some key considerations when you're thinking about data preservation. You want to err on the side of keeping more data for more time, but some highlights. You should consider retaining data that you've used in publications and reports. as well as data that you plan to reuse. So that second part's sort of self-evident, right? You want to think about keeping what's irreproducible. So if you have observational data, that would be hard to capture again, hold on to that. Raw data are usually worth preserving. If data can be easily or automatically recreated from raw data, you may not necessarily need to preserve that. You also want to be thoughtful about space requirements when you're deciding on whether or not to preserve data. There are sort of standard storage amounts that you receive as part of being a faculty member here. And so that might, how much you've used might play into what it is you want to keep. Algorithms and software source code cost very little to preserve, and they can be helpful when, making your data reusable. Results in analyses may be particularly valuable for future discovery, and they also cost very little to preserve. So generally, federally funded research has to be preserved for a minimum of 3 years. Specific funders may have different guidelines, and so you want to be sure of those upfront. So again, when you get funding, make sure that you're aware of the obligations of that funding. Additionally, data that's involved in misconduct investigations or patents will require longer-term preservation. You don't want to think about being involved in misconduct investigations, but that is a consideration. So generally, a good rule of thumb is to keep data for 5 or 10 years. You can always revisit your decision to save data. You can always get rid of it, and it doesn't hurt to hold on to data that you do think may have value. Again, you want to make sure, though, that you're meeting policy and regulatory requirements when you are discarding or preserving data. It's also noteworthy that data retention and data sharing are linked. So data sharing implies long-term preservation of a subset of data that are associated with your findings, and that's usually done in a repository. There are some clear goals and benefits of preservation, and those are that by preserving your data, you're enabling reanalysis of the same products to determine whether the same conclusions are reached. So again, getting at the reproducibility crisis. Preservation enables the reuse of products for new analysis and discovery, so speeding up discovery, and then enabling restoration of original products in the case that working data sets are lost. And so on the topic of data sharing, I'm going to hand things over to Kathleen.
Thanks, Emily. Okay, so your data management plan will probably need to address if and how you will share your data. So when you're preparing to share your data, there are a number of things you'll need to consider, and these will ensure that your data will be discoverable and useful and ethical. And it's best to consider these things before you begin your research because they'll save you time and help you. So these plans aren't meant to be tedious, they can help you. So documentation is one of the most important things, and that can be seen in that data sharing video. And some useful documentation is a metadata standard, but also a README file. And these files let users know important information about the data, like any contact information for people associated with the data, any data collection dates, locations, any keywords to describe the data, methods of data collection, if you used any controlled vocabulary in your metadata, your funding, your licenses. You can include a recommended citation for your data, software or instruments used, the units of measurement, abbreviations, etc. And you should also consider the file formats and how you'll name those files before you're beginning your project. And we talked about that a little bit. So the researcher in the video used proprietary software, and that produced a file that the other researcher couldn't easily open and read. So if you can, it's best to consider using non-proprietary formats, or at least file formats that can be converted to non-proprietary. But at the very least, if you have good documentation, such as a README file, the users that you share your data with will have enough information to know how they can access the data. You'll also need to address licensing and confidentiality, which we discussed a little bit already. So for licensing, consider if copyright applies to your data, and if so, are you the copyright owner? You have a variety of options of licenses to consider, such as Creative Commons. But if you're using somebody else's data, however, you do have to know if you're even allowed to share it. So you'll need to check the license, and feel free to ask the libraries for help with that. One thing you can use to help preserve your data and access to it is to use a persistent identifier. So those are identifiers that will be maintained over time. So for instance, I'm sure we've all used a broken link because it wasn't maintained, a broken hyperlink. So one example of a persistent identifier, which many of you have probably seen, is a DOI, and you've possibly seen those associated with journal articles. And DOIs can also be added to data sets, and some data repositories will even apply that for you. Finally, data can and should be cited, and data citations can provide the same benefits as other citations in that they can provide attribution and increase the discoverability and reproducibility of your data. So first, you should check if the repository you've chosen has a preferred format. Some do. Otherwise, different citation styles have different guidance on citing data. And as always, the libraries can help you with finding information on how to cite your work. So as you write your data management plan, you'll need to consider if you're going to share your data. And you have a number of options if you elect to share it upon request, such as via email. The good thing about that is you will control access to your data, but you must also maintain it and make sure others have your current contact information. You can provide the data on a personal website, and that can help it get cited, but you must ensure that the links continue to work. Some journals let you attach your data as supplemental material when you submit your manuscript, and they can easily track those citations, but your data may not be accessible to others. It may not be freely available, and they may cease providing access to it in the future. Finally, you have some data repositories where you can freely upload your data, and some examples of those are Dryad, ICPSR, Zenodo, and the Open Science Framework, or OSF. Some of those repositories are general and some are subject specific. But if you're considering a repository, UAlbany does have an institutional repository that we call Scholars Archive, and it can house your publications as well as your data. And we are also in the process of getting the capabilities of assigning DOIs to the content in the repository. So please feel free to contact us with any questions regarding the repository or where you could share your data. And at this point, I'm going to just give a brief demo of DMP Tool, which we talked about a little bit at the beginning. So I'm going to change my screen share. So hopefully you can see DMP Tool here. So DMP Tool, it's a free tool. It's run by the University of California Curation Center. And this helps researchers because they provide templates and guidance for creating their data management plans. And UAlbany is now affiliated with DMP Tool, which means that we've added UAlbany specific links and guidance within the tool. And so to use the tool, you just go to dmptool.org, and we have links to it on our data services site as well. And you go to the right and click sign in, and you'd want to use option 1 because we're affiliated. And you could just type in Albany. and then log in. So on this dashboard, we see in the upper right, we have some links. So we have links to the University Libraries Data Services page, to ITS, to DMAC, and the Division for Research. And we also have a link here where you can email the libraries with data services questions. And you'll see I have a couple of test plans here. So when you create a plan, you'll be able to see them on the dashboard. But to create a new plan, you could just either click here or this Create Plan button. So to begin with, you'll be asked for a title. And since this is just a test, I'll just click this button, say it's a mock project, and you'll list your organization, and then you can select a funding organization. So if I just begin to type in NSF, I'll get the National Science Foundation, and then if I click that, I can select a template from NSF, and I have a number of options. I'll just select a generic one for now, and then create plan. So next on this page, I can give some more details about my project, the title, the abstract, dates, grant numbers. And we see here on the right that we have some guidance, and by default here, we'll see some guidance from DMP Tool itself and UAlbany since we're affiliated. But you can add up to 6 organizations. You just click see the full list and just click some more and then click save. And then in this next tab, the collaborators tab, it will let you invite your collaborators so that they can work on the project alongside of you. And you can also specify the permissions that they can get. So if you only want somebody to be able to read it, but not edit it. And then in the Write Plan tab, this is where you can create the plan. So we see here the questions in this template. And for instance, if we go to one of these under guidance, we can see this is NSF guidance for this template. There is guidance from DMP Tool. And then UAlbany has some guidance as well. And here we have some UAlbany specific links to ITS and IRB, etc. And then when you're ready to download, you have some options. You can select the type of file you'd like to create, the fonts, etc. And when you're ready, you can also choose whether or not you want to make this plan public or not. And finally here we see at the bottom that I cannot complete this plan because it, number one, is a test project, and I didn't answer at least 50% of the questions because it's a test. But you'll see here that another requirement is I've identified my funder and I've linked to my ORCID account. So if you don't already have one, I'd encourage everyone to sign up for a free ORCID ID. And this is something that you may have noticed on journal articles next to an author's name. And this is a persistent identifier for individuals, and it helps you distinguish yourself from others, especially if you have a common name or you change your name. So your research will be associated with your ID. So to add your ID to DMP Tool, you would either click this, or you could get to it by going to your name and then third-party applications. And then mine's already associated, but it's simple to add yours. And then the last thing I wanted to show about the tool is just that up here under Learn, you'll see DMP Tool has some funder requirements. There are some publicly shared plans that you can view, which may or may not be good, and some FAQs and some other guidance from DMP Tool. And then, of course, as always, feel free to contact us for questions about the tool or where to get assistance with your plan. And now I'm just going to go back to the presentation. And I think Emily is going to talk about other resources that are available to you.
Okay, great. Thanks, Kathleen. Yeah, we just wanted to again let you know that there's help. Again, we recognize that this may not be intuitive. You may not be aware of all the services available on campus, and we've worked really hard the past couple years to make sure that we're trying to provide coordinated support between the different units on campus that have different areas of expertise. And so you'll see here, the libraries can really help you find and provide best practices for managing your data. We do provide support for DMP Tool. If you would like feedback again on a data management plan that you've drafted, we can try to help you with that. And we can also provide data sharing and preservation support. So Kathleen mentioned Scholars Archive, and we can help advise or answer questions about, we're not lawyers, but we can answer questions about licensing or copyright questions that you might have. We're really fortunate to be able to work so closely with Sandra and the Data Management Analytics Center. They can provide a lot of help around data collection, documentation and metadata, and then consultation on ethical considerations. And we've also been working with ITS on privacy and security standards that we mentioned, storage and backup, and then computing resources. And there's a lot of there's a lot of development, I think, in ITS and sort of the support that they're going to be able to provide to projects around the NIST requirements that Sandra had mentioned earlier. So more to come on that front. So next slide, please. We wanted to, again, we will be sure to share the slides with the folks that have signed on here. And so these are links to the UAlbany Data Services page and DMP Tool. I dropped DMP Tool in chat. I was kind of slow on that. I apologize. And then also to the Data Management and Analytics Center, ITS, and sponsored programs. So this really is a network of support that we're working across the university with folks on. So next slide, please. We just wanted to provide a shout out to our credits. For those of you who are interested, the Christian Briney book that we've referenced here is a really good handbook. So I'd recommend that if you want something on your desk that you can sort of flip through and get golden nuggets from. That's good to have on hand. And then last, we'll just turn things over to you for questions. I'm going to stop the recording now, though, so give me 1 second to do that. So